Okay, let's see if they can find me. Ah. Hello, Alicia. Don't you love technology? It's either very, very good or very, very bad. Downright evil. Okay. Well, we do what we can, huh? Okay. Alicia, ma'am, what was your question? We can at least get to that one. Give me your page and your question number again. Hello, Amina. Hello, Errol. Thanks for reconnecting. Sorry, all of you. Technology. What can you say, huh? Good. 488, number 9. Let's do it. So page 488, everybody, number 9. Lizzie's suggestion. And let's see. Thank you, Lizzie. The following is equilibrium with atmospheric pressure of 1 atmosphere in all parts. Okay, a thin layer of catalyst near the, well, that's interesting. A thin layer of catalyst near the open valve causes the gases to react to form ammonia. Give the partial pressure of each gas and the total pressure in the system when the reaction is complete. Wow, that's cool. Okay, so it's 1 atmosphere, and I got 2 liters H2, and I got 1 liter N2. And on top of everything else, I'm going to make ammonia out of it. Okay, who knows what ammonia is? Hi, everybody. Thanks for coming back. What's ammonia? Ammonia, not ammonium. Probably a good chemical to know. It's in a lot of cleaners, ammonia, and it's used in a lot of industrial industries. NH3, thank you very much. Now, you remember Le Chatelier's principle? If you don't, it's in the gas chapter, and it says, hey, if I got the same pressure, then these are going to be really similar to number of moles. So essentially, I want you to think, although it says 2 liters, I got 2 times as many moles of H2 as N2. So my question to you is, let's figure out, this is a limiting reactant problem. Even though it doesn't sound like it, we got to get the partial pressures of each gas. It's a limiting reactant problem, and let's see who we run out of. So I got enough. Here we go. 1 liter of N2 could make how many liters of NH3? Right? So for every 1 liter of N2, I could make how many NH3s? Hello, Bella. I could make, well, there's 1 N and I've got 2, so I can make 2 liters of NH3. And that, I think, is about all I can make. So I can make 2 liters NH3. What if I used up all of this stuff? I got 2 liters of H2. Well, for every 1 liter of H2, oh, that's really not easy, is it? I get how many liters of NH3? Well, it's kind of a crappy ratio, isn't it? So I need basically for every 2 liters of this, well, let's make it 3. For every 3 liters of this, I get 2 liters of this out of there, don't I? You know what I'm saying? So I'm trying to figure out a ratio here for every 2 liters of NH3, it's got 3 liters of H2 in it. So that's just a fraction to help us figure out how many moles. So what that means is 2 times 2 is 4 divided by 3. I got 1.33 liters of NH3. Here's why I'm doing this, Lissy and everybody. It says, what's the partial pressure of all your gases? Well, what have I run out of? There's no more what in there. What does this tell us? Which one have I run out of? And what's the most I can make of NH3? Can I make 2 liters or 1.33 liters? So help me out with either one of those questions. What's my limiting reactant? What's gone? And what is my yield? My yield. How many liters can I make? Exactly, 1.33, and limiting reactants H2. Good. Okay, so the H2 is gone. So what we've got is we've got 1.33 liters of NH3. But now we got a new problem. We got to figure out how many liters of this stuff is left. So let's take this. Ready? 1.33 liters of NH3 times we got 2 liters of H2. We got to see how much H2 is left. Okay, how much H2 is left? So for every 1 mole, let's make it liter, 1 liter of NH3, I get 1.5. Oh, that's sort of crappy. How about we say for every, same as up here, for every 2 liters of that, I get, did I do that right? No, I didn't do it right. But we're going to do it right. Okay, so I've run out of H2. I want to see how much nitrogen is left. Pardon me. So if my limiting reactant is that, that's gone. Gone. So what I'm asking is how much is left? And that's in liters. So we're going to do that right here. Okay, so 1.33 liters of the product. Well, for every 2 liters of that NH3, I get 1 liter of N2. So what that means is I got what? 1.33 divided by 2. Can somebody do that on a calculator? What is that? 3/4 divided by 2. Holy moly. Probably it ought to be nicer that way. So that's 4/3 divided by 2, which should be times 1/2. It should be 4/6. Is that right? 2/3? Is it 0.66 or something like that? Yeah, how about that? Good. I'm happy my brain's still working. 0.667 liters of N2. Okay, man. It's not a hard problem, but it takes a little thinking, doesn't it? So you may have to rewind this video, which I'll send to you, what's left of it, and think about all this later. Anyway, I had 2 liter, no, I had 1 liter of this, so I got to take away the amount that was used. So that's the amount of N2 that was used. See what I'm saying? So let's take that away. So take away 0.667 liters of N2, and I got 0.333 whatever liters of N2 left. So I got this, and I got this. And now we can actually answer their question. All right, let's go back and see which one they want. Give the partial pressure of each gas and the total pressure in the system when the reaction is complete. Now, I don't know, Alicia, if I'm understanding this correctly. I'm assuming the valve is then open. And if the valve's open, then it's still 1 atmosphere. No, it's not necessarily 1 atmosphere. Then it's some new pressure. So let's start again with calculations. I need a relationship before and after. Okay, so pressure times volume they're going to have it a way I probably don't like. I want a pressure volume relationship. There it is. Okay, so P1 V1 equals P2 V2. I bet somebody even wrote that down already. No. Okay, well, that's what we need here, don't we? Because we got pressure and we got volume. So let's let this be the pressure afterwards. So P2 equals final pressure. All right, you ready? Yes, I know there's another question, but let's get this one first. Okay, so P2 is going to be, okay, P1 was 1 atmosphere, right? Times V1 was how much total volume? 3 liters. Equals P2, we don't know. What's our final volume here? Add these suckers up. Oh, now it's less than 3. Now it's 1.66 or 67 maybe if we round it better. And I'm going to say P2, that's the total. So that equals blah, whatever. Okay, you can figure that out. And it'll be in atmospheres. Now, the other thing they want is the partial pressure. Well, look back. Hey, look at this. Don't I have basically this much of it is, this much out of the total is, here, let's just give you a clue. Okay, so the partial pressure of NH3 equals essentially the liters of NH3 here divided by the total liters times this P total. You know what I'm saying? So it's this ratio of the liters, that divided by the total, times the pressure total, which you'll get up here, and same with the other one. The pressure, the partial pressure of N2 is just the liters of N2 divided by the total liters times the P total. I can do that because the valves are open and it's the same pressure throughout. Okay. All right, I'm going to let you finish that up. And I hope, Alicia, let me know in the class chat if you don't get the right answer this time. But I hope that's the answer Cheryl has, because I think that's the way to do it. I don't think I screwed up on that one. And we're very much, I guess, out of time. Thank you, all of you, for hanging in with me. I'm sorry about the broadcast, and I'll take more questions from you actually at any time. If you have a question about some of these and it's bugging you, just do it on the class chat, or if it's really long, email me, okay? And I'll write you back with a little idea for chapter 8, okay? And then once you get all done that you can on chapter 8, start on chapter 1, whenever. Have a nice Christmas first, though, okay? So we'll come back and we'll start to talk again. We'll do a live stream, or if you want, we could do a Google Meet instead if you wish, and I could see you, and it might be easier for you to communicate. And we'll do that in the beginning of January. Okay? Let's keep each other on track. Thanks all. Happy holidays to all of you as well. I'll send you this little part of it. I don't know if I can send you the first part, but I'll send you this part for those that couldn't be here. Thank you. Thank you all.